You are welcome to my channel. The name is Daniel, and in today's video we have a question under conditional probability. If this is your first video, I will advise that go in the same playlist, conditional probability. You will find series of introduction there. These videos are very important. I have explained the introduction into details, and I've given you different types of formulas and how to use them. So go through them before you tackle questions of this sort. I have series of these examples on the page that you can go through with me to equip yourself under this topic. So let's see what we have today. In today's exercise, we have a question that says, in a factory, machine A, B, and C produces electronic component. It says that machine A produces 16% of the component, machine B 50%, machine C produces the remaining component. Some of the components are defective. Machine A, B, and C produces 4%, 3%, and 7% defectives respectively. Then the first question is that draw a tree diagram to represent this information. Then find the probability that a randomly selected component is 1. Defective, C or B defective, C produced by B is defective, and D, given that a randomly selected component is defective, which machine is likely to have produced it? So this is a different exercise under the series of exercises we are doing under this topic. So let's begin with what we have today. So the first thing we will do is to write down our data. Okay, so let's write down our data. So the question gave us the probability of A, which was 16%, 50%, and the remaining was given to C. So we have probability of A giving us 16%. Then we have probability of B gave us 50%. And finally, probability of C gave us 34%. So once we add 16 and 50 together, we subtract from 100, we know that we have the remaining to be 34%. Now, watch, he gave us the defectives. Some of the components are defective. Machine A, B, and C produce 4, 3, and 7% defectives. Now, listen carefully. We know that when the machine was producing the component, it generated some defective. So now we are going to write this as the probability of the defective given as A has occurred. Okay, when you watch the introduction, you understand. So we are taking the defective, we are finding the probability of defective generated coming from what? Plant A or machine A. So that gave us what? 4%. Then we go to the probability of the defective generated that came from what? Plant or machine what? B. And that gave us what? 3%. And the probability of defective as C occurred gave us 7%. Now the next thing we will do is that let's put the three machines in a diagram and represent their defective together. Okay, so this is the diagram. From this diagram, I will divide this into 3. Let's assume that this place is A, this place is B, and this is C. Their intersection will be D. So we will put the defectives here. So let's shade this side. Now that we understand this, we can go to the first question. The first question says, draw a tree diagram to represent this information. So we will draw a tree diagram here. So this is my first branch. Because we have 3 plants, we will have 3 branches. This is my second branch, and let's assume this is my third branch. So this side will represent plant A, plant B, and plant C respectively. Now each branch will split into 2. One will take the defectives, one will take the non-defectives. Okay, now we have the defectives here. So this side will be probability of D as A has occurred. So this is equal to 4%, which is the same as 1 out of 25. Then we move on to this side, plant B or machine B, which is probability of the defective as B has been given, gave us 3%. 3 divided by 100. We go to plant C. We have P of D giving C is giving us what? 7%, which is 7 over 100. Now, plant A, which is on this branch, has a probability of what? 16%. So we put it here. P of A is equal to 16%, 4 out of 25. Probability of plant B is the same as 50%. Now this 50%, when we divide by 100, we have 1 out of 2. The next thing is probability of C. So P of C is giving us 34%. Now when you divide the 34 by 100, you have 17 divided by 50. The next thing we need to do is to go to the question. It says that find the probability that a randomly selected component is defective. So what is he looking for? He's looking for this D, the D we have here in the intersection. And to be able to get this D, what are we supposed to? We need to find the D for this, D for this, D for this, and sum up this result together. And that will give us the answer. Okay, so let's see what we have here. To be able to find D, the probability of D, we need to find probability of A intersection D, probability of B intersection D, probability of C intersection D, and sum up the result together. So probability of D is going to give us probability of A intersection D union probability of B intersection D union probability of C intersection D. The union here means addition. Okay, so when I'm writing, I'll change it. Now watch here. We said that we are looking for the probability of what? D as A has occurred, or giving A, B, and C at the same time. Now watch here. If I take the probability of D as A has occurred, for example, P of D giving what? A. Probability of the defective generated from what? A. Then it's going to give me the event P of A and D occurring together divided by the probability of the event what? A. When we divide this by 1, which is already there, and we cross multiply, what happens? This multiplies this. So I have probability of D as A has occurred times the probability of the A. Okay, so now this is what is standing for the intersection, because everything here is equal to A intersection D, which means the event A and D occurring together. Do you understand? Because the defectives were generated when the plant A or the machine A was generating the component. So that event, it happened together. So this side is going to give us what? Probability of A times the probability of what? D as A has occurred plus probability of the event B times its conditional probability, which we already have here, D as B has occurred, plus the probability of C times its conditional probability, P of what we have here is D as C has occurred. Now when we substitute these values, this is giving us probability of A gave us what? 4 over 25. So we have 4 over 25 times, what is the probability here? We have 1 over 25 this side plus probability of B gave us what? 1 out of 2 times its conditional probability 3 over 100 plus we have probability of C, which is 17 over 50 times conditional probability is giving us 7 over 100. Now when you punch this on your calculator, run it to 4 decimal place, we have 0.0064. Okay, plus when we do this, we have 0.015. When you punch this side, we have 0.0238. I think this value, when you run, you are getting it in 3 decimal place. Okay, it's still. Now when we sum everything together, we have our probability of D is giving us 115 dividing 2500. This is 0.0452. The probability of selecting a random component which is defective is giving us 0.0452. Let's move on to the next question. The next question is saying find the probability that a randomly selected component is produced by B and that it is defective. Okay, so we've already done that. Okay, that is very simple. We've already done that, and the result we got was 0.015. So though we are looking for B intersection D, we need to quote the formula. We already have the answer here. We can't just write it down. So now what's something? Because we are conditioning on B, let's write the conditional probability formula together. Okay, so we have P here, and we are finding the defective conditioning on what? B. Okay, and that is going to give us probability of what we have here. B intersection D out of P of what? B. Now when we cross multiply, what do we have? Probability of this is going to give us probability of B times its conditional probability D as B has occurred, which we already know. So this is the result. So we have 1 out of 2 times 3 over 100, giving us 0.015. So now as we move to the last question, you said that given that a randomly selected component is defective. Now watch carefully. This time we are conditioning on what? The defective D, which we already have. We are conditioning on this D, which we already have here. So which machine is likely to have produced it? Now, because we don't know which machine is likely to have produced the highest defective, we need to find the higher defective for all the 3 plants. Okay, plant 1, plant 2, and plant 3, or machine 1, machine 2, and machine 3. Let's see what we have. So now we are looking for the probability of A given D, which we already have, and this is giving us the probability. You know that we will have A and D occurring together divided by probability of the one we are conditioning on, okay, D, and this is giving us A intersection D. We already have the result. Okay, what was the result? It gave us 0.064. So we have 0.064 dividing probability of D was 0.0452. Okay, so P of A as D has occurred is equal to 0.1422. So punch this on your calculator, you have this. Please correct me if I'm wrong. Okay, the next thing we'll do is to find for plant B. So probability, let's write this together. Plant B as the defective occurred is giving us probability of B intersection D divided by probability of D. All right, did you get that? So this is giving us, we already know that probability, 0.015. 0.015 divided by 0.0452. So probability of B as D occurred gave us what? 0.332. Okay, then we move on to the last one. This is giving us 0.0238 out of 0.0452. Okay, and when we divide that, we have P of C as D occurred is giving us 0.526. So now look at these 3 values, 1, 2, 3. Which is the highest? The result is this. So it means the defective was generated by what? Plant C. So the higher the value, we are saying that plant C is likely to have generated the what? the defective, okay, because it has the highest what defective rate. When you look at this side, it will even tell you, look at plan C, look at the percentage of defective it generated, 7%. Okay, so that should tell you that the answer should be this one. All right, if you still don't understand, but always remember that when you get here, anytime they are trying to the question asks you to find which plant generated a defect or which machine generated or whatever you are using, all you need to do, find the defective of all the three plants. When you finish, look for the highest value, and that plant or machine is likely to have produced it. Okay, and so that will be all for this exercise. Please subscribe to this channel if you haven't, share these videos with your friends, and I will see you in the next one.